Hi guys, in this video I am going to talk about mapping data warehouse to a multiprocessor architecture. When you are mapping a data warehouse to a multiprocessor architecture, then it should perform two main functions, that is linear performance and scalability. Why linear performance? Your data warehouse that you are mapping to a multiprocessor architecture means your data warehouse is present, and now this data warehouse, how it can be shared with different multiprocessor architecture, or how this data in the data warehouse is going to process. For this, linear performance and scalability must be present. Linear performance means whatever the performance this data warehouse is having, if you are mapping this to a multiprocessor environment, then this linear performance should not be in imbalance. And scalability means if you are adding more data, or if you want to increase the size of your data warehouse, then scalability is required. And this mapping process should not disturb the scalability. Means suppose now you are mapping your data warehouse to different multiprocessor environment, but now scalability is reduced. Means now previously if you were able to expand your data warehouse to a 10 to 15 subjects, but after multiprocessor architecture you are not able to expand it, so this should not be present. So linear performance and scalability can be performed by parallel hardware architecture. So what is this parallel hardware architecture? This parallel hardware architectures are based on multiprocessor systems. These parallel hardware means you are having your database. Now this database requires main memory and physical memory. Now how you are going to share this main memory and physical memory with different processor? So parallel hardware architectures are based on multiprocessor system designed as shared memory, shared disk and distributed memory models. Now let's discuss each. First is shared memory. Shared memory means multiple processor share main memory and hard disk. There are different multiprocessor present. Now this different multiprocessor share the same main memory and same hard disk. So this is shared memory architecture of parallel hardware. Now second, shared disk. When you are following the parallel hardware architecture and of shared disk, then each node have its own main memory, but all nodes shared same disk. It is like you have connected a phone with a computer. Now phone has its own main memory and computer has its own memory, but both are going to share the same hard disk. So in shared disk, each node has its own main memory, but all nodes share same hard disk. Shared nothing means each node has its own main memory and hard disk. Parallelism can be achieved in three different ways. If you want to achieve parallelism means having there is a task given and you want to divide the task on the basis. Suppose a task is given to different processor. One part of the task is given to one processor, second task of the process is given to the second processor, and so on. Means you are following parallelism. Parallelism means doing a work at simultaneous way. Means two processor can process files simultaneously. So how you can achieve this parallelism? This parallelism can be achieved in three different ways: horizontal, vertical and data. Horizontal means different disk. When you want to achieve parallelism using different disk, this means when you want to divide your task based on different disk, means each processor having its own disk. Vertical means different task. When you are doing this division based on the task, you can divide the different processor with different amount of tasks. Suppose processor A solves the problems related to memory, processor B solves the problem related to technical, problem C solves the problem related to speed. So when you are dividing your task based on task, then it is a parallel, it is a vertical parallelism. Now third is data. When you differentiate using data, means when you are achieving parallelism in comparison to data. Suppose different sets of data are there, like for physics a data is there, chemistry data is there, mathematics data is there, and now you are dividing this different datas on different processor, then it is a parallelism can be achieved on data. This was all for the mapping data warehouse to a multiprocessor architecture. Thank you.